So, welcome. We're going to start today on all handpiece repairs. We're going to start everything from the basics, going through all the different manufacturers that are out there, how the handpieces work, how they operate, and a lot of the components that are involved in handpieces. So we'll start. Pneumatic high-speed handpieces. There's two different handpieces out on the market. There's pneumatic, which is what we're going to go over now, and then there's electric, which is a whole nother training course. So these pneumatic, which is air driven. So everything's done through compressed air. These are the most common manufacturers that you're going to see. This isn't all of them, but this is kind of the most popular ones out there. Midwest is the originators of the handpieces. They've been out forever and a day. They're owned by the Dentsply company, and they're probably one of the most popular handpieces out on the market. They've got a couple different models that they have, but they're probably the most popular that you're going to see when you compare price point and things like that. You'll probably, just about every market's flooded with them. Star is part of the Dentalese group, and you guys are dealers for Star. That's a handpiece you can sell. We have a whole demo kit that we'll go over that you can sell through, demo for the doctor, things like that. So you're a Star dealer. It's a great handpiece. When you compare the price of them with the features, the torque, the cutting ability, they're phenomenal handpieces. Cabo is probably the most high-end and high-priced handpiece out there. You're not a dealer for them, you can't sell them. You can service them, you can do the repairs on them. But they're really high-priced handpieces. A lot of their newer stuff probably averages about $1,200 to $1,400 a handpiece. So they're high up on on the end of the pricing scale. Layers is a company that deals directly with the doctors. It's a doctor direct company. You can service them, you can do the repairs on them, but Layers sells directly to the doctor. So if the doctor's interested in purchasing those handpieces, they go direct. So obviously that means you're not a dealer for them. NSK, most are cartridge style handpieces, which we'll get into that, what the cartridge style means. What it means for you is the repair takes about 5 seconds and you get to charge a lot of money. So that's always good. Quick repair and you get to charge a lot of money for it. ADEC W&H. W&H is the handpiece manufacturer, and they make the handpiece for ADEC. When we get into it, you'll see that ADEC is probably one of the larger companies in the dental industry as a whole. Chairs, lights, operatory equipment, the whole 9 yards. W&H makes the handpiece for them. It's sold exclusively through ADEC. It's another very high-end handpiece, very high-priced handpiece. Again, you're talking well over $1,000 per handpiece, depending on the features and options that it has. You'll see as we get into handpieces, it's kind of like buying a car. You can buy a base model, or you can add options to the handpieces. So they go in varying prices. Same thing with the Star that you can sell. There's a very inexpensive Star all the way up to a very high-end titanium bodied Star handpiece that goes up in price. So just like buying a car, depends on the price point you want to be at. B&Air is another high-end handpiece company, and you're a dealer for them. That's your high-end, high-priced handpiece. They have handpieces that go up to about $1,800. It's a carbon fiber bodied handpiece. It weighs like nothing. I don't know what the point of it is besides the cool factor. But they have handpieces that range from a few hundred all the way up to, like I said, about $1,800 for their carbon fiber handpiece. So the last one is on there is Sirona, which is sold exclusively through Patterson. You can do the repairs on the Sirona handpieces, but again, you can't sell them. You can't. You're not a dealer for them, but you can do the repairs on them. So you're going to come across a lot of other makes and models. Henry Schein, which is one of the big three. They are the biggest of the big three. They have their own branded handpiece. Patterson also has their own branded handpiece. They basically contact companies in China that make, thousands for pennies on the dollar and just say, hey, stick our name on them. So you're going to come across a lot of different makes and models and brands. If you come across something that you're not familiar with or you're struggling to find parts with, like I said, send us a picture of it and chances are we can tell you it's a knockoff of something. There's a lot of companies out there that will knock off a handpiece, make it look like a different handpiece, and it uses the same components, just looks a little bit different. So we can easily identify those for you and help you find the right parts for that particular handpiece that you're working on. Handpieces connect to the handpiece hose in two different ways. As we get further into it on these units, there's a bunch of these by all the desks. This is the handpiece hose. Okay, this is considered the handpiece hose. It's connected to the delivery unit. We'll get more into that as we get into the delivery unit section of training. But basically this is rubber tubing that runs up to a nut and a coupler, and the handpiece or coupler screws on to here. Okay, it's going to connect to that hose in a couple different ways. The first is a standard connection, and I can pass these around as we go through them. The standard connection, which is also known as a fixed back, you're going to have a series of tubes at the back of the handpiece. Okay, this is standard, the cheapest way you can purchase a handpiece. Everything is fixed, internal, nothing external, no couplers, no quick connects, no swivel, just a fixed back. Okay, the next is called a quick connect, which is basically a swivel back. Okay, you can see the difference. This one has a big hole in the back of it. The reason for the hole is it takes what I was talking about before, the swivel couplers. Okay, so the coupler has all the ports on the back. The coupler would screw into the tubing, like so. Coupler screws into the tubing, and now the handpiece clips onto here. This allows the doctor to be able to work and smooth the handpiece without this whole hosing system binding up. It also allows him to quickly, at the end of a procedure, pop this off of here, clean it, sterilize it, and use it again. When you have a fixed back like these, what's going to happen is the handpiece is going to be directly connected to the tubing. So now when the doctor's working, this is you can see sometimes it binds up on them. They'll tell you sometimes that as they're doing a procedure and they're reaching really far back, this will actually kink and cut the air supply to the handpiece. Chances are the tubing's really worn out. You get to replace the tubing. You have tubing on your truck, you can replace the tubing on these. But it doesn't give the doctor as much flexibility when he's working to have a standard back than the couple back. Obviously, this raises the price of the handpiece because now the doctor's got to buy a bunch of these couplers to go on all his operatories so he can quickly connect and disconnect these handpieces. I'll pass these around so you guys can see the difference in them. These just, you can do this by hand, it just pops in and out.
What's the name of that handpiece again, Ricky? That one?
This one?
Allow the flexibility.
This is the quick connect, the swivel back. Okay. And then this one is the standard or the fixed back. You guys can pass those around. Each manufacturer has its own style of coupler, so keep that in mind. As an example, that's a B&R coupler, that's a Cavo coupler, it's a W&H coupler, that's an NSK. So here's just 4 different ones right here. Oops. So, and they are not interchangeable. Obviously, you can tell just by looking at them, they look completely different. So obviously this isn't going to work with this handpiece. Some manufacturers though will offer a different style of coupler. The thought process is, well, wait a minute, if the guy's got a bunch of Cavo handpieces with Cavo couplers and I want to sell him my handpiece, it's probably easier to get the sale if I don't make him buy 5 more couplers, because those couplers, depending on the features, can be anywhere from $200 to $350 each. So to help with handpiece sales, a lot of the manufacturers are allowing their handpieces to work with other couplers. So you can sell other handpieces and not have to worry about selling the doctor a boatload of $250 brand new couplers. So depending on the manufacturer out there, you can see if what you need to sell matches up with what he already has. And however, Cavo being the most popular and most high-end handpiece out there, a lot of the manufacturers are making them especially work with the Cavo. That's going to be your most common you'll find, is that a lot of handpieces work. You can order them with Cavo style backing. Layers, who we talked about earlier, who sells Dr. Direct, used to make their own coupler with their handpieces. Layers said, you know what, we're not the most popular handpiece company out there, so now all of the Layers handpieces come with Kavo quick couplers. So you can't order a Layers with a Layers coupler anymore. They only come with the Kavo style coupling. So that's the couplers. Handpieces and couplers connect to the handpiece hose in 3 different ways. 4-hole, which is your standard configuration, which is no fiber optics. Fiber optics is the light source that if you look at if you look at this handpiece here, actually let's go with this one. So if we look, there's 4 holes on the back of here. Okay? On the next slide, I'll explain to you what the different holes are. So there's 4 holes on the back of this one. No fiber optics. If we look at this one's got 5 holes on the back of it. That 5th hole right there at the top is a glass rod that runs the entire length of the handpiece and comes out right here by the face. I'll pass this one around. That glass rod is there so when a bulb is emitted up from the bottom, the light transmits up and out of the head of the handpiece. So where the doctor is drilling, he's got immediate light at the drill point. So where he's cutting your tooth, he's going to have visible light right at that point. He's also going to have his overhead light on. You know, some doctors don't even, we'll get into it, but some doctors aren't using the overheads anymore. They have the little headlight that they use now. So he'll still have that light source, but this gives him immediate light right where he's drilling. Okay, so this is a 5-hole, and I'll pass this one around. If you hold this one on, our lights are off right now, but the batteries in that. None of my flashlights are working. If you hold this one up to the light, you can actually see where the light comes out if you want to turn on your cell phone light or whatever, but it's a complete glass rod that runs through that handpiece. The second way it connects is a 6-hole. The way a 6-hole works is where's my 6-hole? Okay, so the way the 6-hole handpiece works is you've got now, instead of a glass rod, you've got 2 electrical connections. Okay, so now the light bulb is here. There's the light bulb. Okay, so what ends up happening is instead of the light being emitted from the bottom, the light is now emitted from the coupler. So you got 2 electrical connections here. So when it makes the signal comes through the tubing into the connections. It lights up this bulb, which then lights up through the handpiece, and you can see the glass rod here on this one. Okay, so that's where you're going to see the 6-hole is in your coupler systems. So the bulb is here. The problem with this, this works is when you use a standard halogen bulb in here, you have your halogen bulb sitting right about here. Okay, this is where the doctor's hand is. Right where that halogen bulb is. If the doctor's got a long procedure, those halogen bulbs, as we know from every other halogen bulb in the world, gets really hot. These handpieces will start to heat up on the doctor. Over the past few years, they've come out with replacement LED bulbs for these. So if a doctor has a light that goes out, a little bulb that goes out on him, you can order him and replace these with LED bulbs. Everybody knows the advantage of LED is they last longer, they're whiter, they're brighter, and they don't emit any heat. So there's an upsell everywhere. Upsell him on LED instead of the halogen bulbs. I'll pass this one around now. You can see the 6 pins on here as your 6-pin option. Very old handpieces use what's called a board-in style connection, which is 2 or 3 holes on the back. I'm not going to get too far into it. You get an adapter on your truck to adapt them from a 2-hole to a 4-hole. But again, the odds of you seeing that are not, unless you're in a really older practice with an older doctor who's stuck in his old ways. You know, I don't think there's anything on the market today that you can buy that's 2-hole or 3-hole. Don't quote me on that, but I'm pretty sure there's nothing you can buy today that's 2-hole or 3-hole. It's a really older style connection. And over the years, they've gone away from that to just standard 4-hole, 5-hole, 6-hole. And, wow, we changed that. That's snazzy. Okay. If you have a handpiece with a board style connection, you'll need to use a 2-hole to 4-hole adapter or 3-hole to 4-hole adapter. We just talked about. So here's the way the handpiece is set up. Okay. These are the old 2-hole, 3-hole style connections, which again you would have an adapter for. I think I have one. So if you look at the way this is, there's 2 holes here, and it adapts it to 4 holes. So those are your adapters. Again, there's the 3-hole, adapts it to a 4-hole. So these are, we'll pay attention to these on this side right now, okay? So here's your 4-hole. You've got your water port here. The water supply comes from the delivery unit, up the hose, through the handpiece, and then comes out of the base where the head is in the handpiece. This one is your chip air / coolant air. Everybody knows when you turn on a hose and you have the hose open, you just get a stream of water. Okay? When you mix in air with that, you mist the water. Everybody sees those misting fans? It's a stream of water, then the fan mists it. That's what basically this hole does. You got water through one, you got air through the other. When they combined at the head of the handpiece, that's how the doctors get that nice mist, that nice spray. It's called chip air or coolant air. When it's in regular use, it's coolant air. It's cooling the tip of the burr where the doctor's drilling. Your teeth are a very hard material. When you're trying to drill through that, everybody's used a drill and tried to drill through metal or some other hard material. The drill bit gets hot, right? So in order so the doctor doesn't burn you, damage a drill bit, damage your tooth, the water and the coolant air mix together to keep that area cool. It also moves everything out of the way as he's drilling. The chip air comes in as an extra feature that not every unit has. It's an added feature that's usually pre-ordered from the doctor. What he has is on his foot control that he's operating, there's an extra button that he would press, and it sends a burst of air through that port to move the chips out of the way. So if he's drilling and something's not moving, there's a chunk of tooth that doesn't want to move out of the way, that's where he would hit that chip air and it blasts the chip out of the way. That's where that comes from. Your 5-hole, add your glass rod fiber optics, that's what we talked about. Your 6-hole is for fiber optics, but it's the nodes. So these are electrical contacts that get an electrical signal. They usually run off very low voltage, 12 volts. I think the highest I've seen is 14 volts or something like that. So you don't have to worry about it. Doc's not putting 120 volts in your mouth. It's all low voltage. And that would then hit the light bulb that we talked about on this one and would light the light bulb from here, shine through the handpiece, and emit the light. You've got your drive air line. These are always the same. The only thing that's going to change is your fiber optics. Okay? If you're holding your water ports up, okay, you're going to hear different ways of figuring this out, the little of the big holes and things like that. The easiest way to remember this is no matter what handpiece you're working on, okay, if we take our water ports, which are these up here, and we hold them up, the port on the left is always your drive air port, okay? You got to remember that. That's always your drive air port. Reason why you got to remember that is when it comes time to lubricate your handpieces, you lubricate in the drive air port. So when you hit the rheostat and that air pressure comes up, it takes that lubricant that's in the drive air line, pushes it up into the head of the handpiece, lubricates the bearings, and then all the exhaust comes out the exhaust port. So you've got an in and an out. It's a big loop, okay? The way these vary is they don't have an exhaust port. The exhaust port is actually, once it goes in the head, it just That's it. That's the exhaust port. It just blows air everywhere. They're loud. It's kind of an annoying handpiece. So over the years, they realized, hey, we should just complete that loop and now let it exhaust through the handpiece. Okay. So if you look at the handpiece tubing, okay, with your big ports, you got your drive air port and your exhaust port. So basically, the air comes up from the delivery unit, up the handpiece tubing, into the handpiece, and it comes back down, back through the tubing, and inside of the delivery unit, you'll see different various setups. A lot of times, it's just an open tube, and it exhausts into the delivery unit. Sometimes you'll see catch cups in there where it catches the exhaust to make it even quieter. You'll see different variations of that. It keeps the handpiece quieter. It also doesn't require as much pressure to run the handpieces because now you're building back pressure. If you just let it exhaust in the air, you're losing a lot of that back pressure. So you get a little bit of back pressure, allows the handpiece to run a little bit smoother. In the original design, they had your drive air and your water, and that was it. But again, the problem with that is your water starts streaming. It's not a nice mist. So then they said, all right, let's add the coolant port. And then they said, well, let's add an exhaust port. So it's modified over the years. That's why now you're not going to see these connections really that much anymore. Everybody's basically switched over to these. Okay. This is basically what a quick connect looks like, which is when you take one of these couplers and you're basically shoving it into here. Okay. This is kind of the internals of it. If you were to take this handpiece and break down how it works internally, you don't have to get too in depth with this. Anytime you do a lubrication, when you're lubricating your handpiece, you lubricate through your coupler. So you can see where the drive air port is on here. You really can't see it on here, but you know, if you looked inside of here, you could find it. But you're not going to sit here and intricately drop that dropper into here. You're going to put this in here like this, and you're going to drop your lubricant into here. And then you're going to put while your lubricant's in here, you're going to put this on here. And then you're going to screw this up. You're going to put this on here. Now you're going to run it to have your lubricant move up the handpiece and into the bearings. Okay? Coolant air and coolant water are used at the burr of the handpiece in order to cool and clean the surface of the tube. That's what we just talked about. There are two configurations that are used to accomplish this. The first way is a single pipe which exits the handpiece underneath the burr. This pipe has a center tube where the water exits and an outer tube which is where the air exits. I'll pass this one around. You can see the single port water spray on here. So you'll hear us talking about single port and multi-port. Okay, this first way is the single port water spray. You got one little port. If you really look, you can kind of see the inner and the outer ports, but they're so small, unless you got really good eyes or one of those little magnifying glasses in the back, it's kind of hard to identify it. But it's there. So I'll pass this one around. That's the single port water spray. Clogging can occur. Running a wire into the tube helps unclog it, or now standard issue on your truck is a really nice water cleaning kit from Handpiece headquarters. I knew that was there. We're going to show you how to use this in class, but the old-fashioned way, we used to have to take really thin orthodontic wire and run it through the handpiece to get the clogs out. Now you get this really nice cleaning kit. Again, I'll show you how to use this a little bit later. Which makes unclogging handpieces 1,000 times easier and faster and less stressful. So lucky you, I didn't have one of these. The purpose of the coolant air is to atomize the coolant water into a mist. We just talked about that before. The second way is multi-port handpieces. Multi-port handpieces gives you a spray cover on the front of the handpiece. I'll pass this one around. The coolant air and coolant water are released under the faceplate and come out through ports on the faceplate. This design lends to itself clogging on the faceplate ports, which interrupts the water flow. This one is a little bit more trickier to unclog because you have multi-ports all the way around the face, and I'll pass this one around so you can see what I'm talking about. The problem with this one is if you have one port that's clogged, you're still going to have water coming out the other two ports. Find the path of least resistance, the water's still going to come out. It's going to give the doctor kind of an uneven spray. He's probably going to say, hey, listen, can you check this and figure out why it's not spraying right? It's going to be any number of reasons. One, the spray plate may have shifted. Maybe he dropped it, something happened, the spray plate shifted and the ports aren't properly lined up. There's also very, very thin O-rings under here that seal this. Maybe the O-rings are starting to go bad. He may tell you there's a little bit of drip coming out of here as it's working. Or just the spray ports got clogged. Again, with this water cleaning kit, it makes cleaning even these multi-port handpieces 1,000 times easier and faster. So I'll pass this one around. You can see what I'm talking about with the multi-port spray. The spray covers on a lot of those handpieces are field serviceable. On the Handpiece headquarters website, which we'll get into in a little bit, you can order the replacement O-rings if the O-rings do wear out. You can also order some of the spray covers if the spray covers get damaged from the doctor dropping them or the assistant dropping them, whatever the situation is. So a lot of that is field serviceable. And if you can't service it in the field, chances are we can service it here in our in-house repair department. So I said at the bottom, shifting of the face plate can occur. And if that happens, you either just need to realign it, or if there's a pin, a little set pin in there, the set pin may have broke, again, usually from being mishandled. There are different types of back caps on handpieces depending on the style of the chuck. Okay, now we're starting to get into the internal components of the actual handpiece. This is what actually make the handpiece work. Okay, you have a push button, which is an auto chuck. Okay, if we look at the back of this handpiece, okay, there's a little button here. Again, I'll pass this around. You can see what I'm talking about. This is the burr. Okay. The burrs you guys are going to be working with in class are blank test burrs. That's what they're called. They're blank test burrs. There's no cutting bit on them. There's nothing. The doctor's actually going to use what looks like a very miniaturized drill bit like you would use on a drill press at home. Okay. I'm going to pass this around. You guys can play with this first. If you push this button in and hold it, it will allow you to release the burr out of the handpiece. And then you just release the button and it goes back to normal. And same thing with putting it back in. You'll push the button and hold it, and then you'll slide your burr in. And that's what locks down the burr. So inside of this, okay, where this burr is seated, there's little mini teeth. And as you push that button in, the teeth are moving and spreading, which is allowing the burr to be released. So when you let go of the button, the teeth retract and grip onto that button. Over time, which we'll get into later, those chucks wear out. And they have to be replaced, and that's where you guys come in on doing on-site handpiece repairs. When the doctor tells you, hey, listen, I'm cutting into a tooth and the burr just falls out. Or I'm cutting on a tooth and I go to pull it out and it just hangs up and it pulls right out. Okay? That's something you can repair, that's something you can service. So I'll pass this around. Each one of you can push the button and pull this in and out. You can see how that operates. The next style is a lever. Midwest is the only company that uses the lever, and the lever works very similar to the button. So here's the lever on the back of here. Oh, I had a lever that worked. So the lever, you'll just flip the lever, and you see it goes into an open position. That's leaving that button engaged, and it allows you to pull the burr in and out. When you place your burr back in, when the doctor places his cutting burr back in, he'll just flip the button shut, and that'll release and allow the teeth to grip back onto the burr. So again, you just flip the button open, pulls it out, puts it back in, flip the button shut. Okay? So I'll pass the lever around. You can see how that one works. The third style is a standard or manual chuck, also known as a Jacob's chuck. This one works similar to a drill press, if anybody's ever worked a drill press or the big drill that you would use. That takes a key. You lock the chuck down with a key. Some of these handpieces take a little mini key like this. Okay. If you look at the back of this handpiece, this one. Okay, if you look at the back of this handpiece, there's a hole in the middle of this handpiece in the back. Okay, the way this works is you take this key and you'll insert it into here. Once you get it lined up. And then once you have the key in here, you'll turn this section of the key and it opens the chuck. Allows you to pull the burr out. You put the burr back in and then you close and tighten the key down. These have significantly less wear to them. These will wear out less because with the key you can just keep cranking it and cranking it and cranking it and cranking it until eventually you can't crank it no more, which takes a very long time. So these will last the doctor a lot longer, the chucks on these. But they also require these little keys which go missing, get thrown away. I've sold the doctor plenty of keys. You can sell the doctor these keys. A lot of times you'll walk in the office and the most common place I usually see them is they'll tie a little bit of dental floss around this and then they'll hang it from their unit. So they always know where it is. It's always hung at the unit. Some of them will always keep these together. You may get one of these for repair in a little sterilization bag, and the key will be in the bag. Make sure you don't lose their key. Okay? I used to just leave them in the office. I never liked to take in their keys. Never wanted to be responsible for their keys. I always left their keys in the office. You get the keys on your truck. It's part of your build out. You have plenty of keys. I'll pass this one around. This one's a little bit harder, especially when you're not your first time ever doing it, to get these keys to line up. You don't have to spend an hour on it. We're going to actually repair these today. At the end of the day, this is the handpiece that you're going to be working on a lot. So each one of you will actually get one of these handpieces. You'll take it apart. I'll have you play with the burr a little bit to get the burr in and out. The one tip I'll tell you from the beginning is when you have a key and you put the key in, you only need about a half a turn to a full turn. Okay? When you turn this key to unlock it, that was one full turn, that's it. Burr's gonna come out. If you sit here and you turn this all the way, you can actually, and I'll show you, you can actually pull the chuck out. Okay? Then it ends up on your desk and you go, what did I do? Okay? So you don't need to pull these chucks all the way out. Okay? So again, and same thing when you're tightening these down, you only need to tighten them down. If you only unlocked them one turn, you only need to turn them down a turn to lock them back. And as we get more into it, nothing in the dental industry, it really needs to be Hercules strength to get done. When you're tightening handpieces, the back caps, the burrs, these are aluminum handpieces a lot of the time. If you crank down, if anybody's worked with aluminum, if you crank aluminum, you can easily strip threads. You can easily strip and damage the aluminum, okay? So don't try to get all Hercules with these handpieces and crank down the back caps or crank down the burrs, because you will cause damage to the handpiece. So I'll leave this in here. And then we'll pass it around. The easiest way to do this is grab this front section here. Okay, so hold it like this with the front section here and spin the back section. You can see it's two separate sections that'll spin. And that's how you'll unlock. And then when you put it back in again, grab the front section and spin the back section until it locks down. And the fourth way is what's called a friction grip. I don't think we have them here anymore. You're not really going to see them anymore. Basically what a friction grip is, it sounds just like it is. You got to force the burr in and force the burr out. Cabo mainly had that handpiece out. I don't think anybody offers a friction grip anymore, just because it's, when you're basically forcing it in and forcing it out, it damages the chuck a lot. But it was an inexpensive way to, just for another handpiece, so where you don't have to use a tool, and you don't have to raise the cost of the handpiece because you're using an auto chuck with a button, like an actual auto actuating chuck. You're just ripping a burr in and out. It led to a lot of problems. If you lost the tool to remove the burr, you had to use pliers and yank the burr out, which led to the burr bending, damaging the handpiece. Just was not a very good design, the friction grip. If you struggle with that key, don't kill yourself over it, because again, we're going to go over them later. I just want you guys to see all the different options there are out there. Fiber optics, we touched on them briefly before. There's two types of fiber optics. There's the glass rod and there's a fiber optic bundle. The glass rod is the most common and what you're going to see the most of. It's just that. It's a glass rod that runs through the length of the handpiece or the coupler and allows the light to transmit from one end to the other. The fiber optic bundles was an older style that Midwest used to use, where there was actually fiber optic bundles running through the tubing and everything. The light source was at the floor, and it would run a fiber optic tubing up through the delivery unit, into the handpiece, and then emit the light.
Seen one was like a little canister, and it had the light bulb in that.
Yeah, a light bulb module. That's a 5-hole to 6-hole. Yeah, we'll get into that's a 5-hole to 6-hole adapter with those. Those are light modules from DCI.
Okay. Yeah.
It basically allows, if you have a 5-hole coupler, to transmit it to a 6-hole to allow.
Yeah, that's what the doctor had.
Yep. Okay. Just another variation of the fiber optics. But that one is still the glass rod style.
Yeah. Yep. It's just the light source was.
The light source was in the.
Now, how does that get power?
That gets a low voltage signal from the delivery unit. So inside of the delivery unit, there's a fiber optic box that emits a low voltage signal, and it actually works off what's called an air electric signal. So you have basically a circuit. Everybody knows an open and closed circuit. You basically have an open circuit. When the air signal hits this relay, it's called an air electric relay, the air signal closes the relay, the electric relay, and allows the current, which is low, again, we talked about it before, it's low voltage, to pass through and then come up the handpiece and then hit, depending on if it's a 5-hole module or a 6-hole, hit that module and turn the bulb on. We have it set up on our units, so when we get back onto the unit, you'll actually see the modules and stuff. But you can install them, you can sell them if you want to upgrade the doctor. You can do all that. So if a doctor has a standard delivery unit and a standard handpiece tubing and wants fiber optics, he's interested in fiber optics, you can upsell all that. You can outfit all these units with full fiber optics. The old style bundle, if anybody has ever done audio with fiber optic audio or anything like that, it's very, very hair thin glass strands that can run over a very long length. To get fiber optics. The problem with that is it's very fragile. You can't do sharp bends with it. It has to be looping bends because it's glass. Anytime you make glass into 90 degrees, it breaks. So it has to be a continuous. So it led to a lot of problems with the strands breaking. That's why most people now don't run that. Nobody runs that anymore. What you'll see, where's our 6-hole, the tubing?
We'll get into it later.
Okay. What you'll see is basically 2 low voltage wires running through the middle of here, coming up, and that's where the low voltage signal comes from. So it looks like standard tubing, but it's not. It's got 2 low voltage wires running through the middle of it. The internal components of the handpiece, it's called the turbine assembly. Okay, that consists of the spindle chuck, which is what you guys were working with, those keys, the chuck. Okay, whether it's an auto chuck, which is the button or the lever or the key. You got the spindle chuck assembly. You have the impeller. Everybody knows what an impeller looks like on an airplane and things like that. It's got the impeller. That's what, when the drive air comes up, it hits the impeller, which that's what causes it to spin. Then you got the bearings, and that's what everything spins on. Okay, those bearings are sandwiched in between O-rings, so they have a nice, comfortable place to sit. And then in some handpieces, you'll find little miscellaneous washers and spacers. Could be called a slinger. You'll see different variations of this, and as we go through the different manufacturers, you'll see all the different all the different variations of those washers, spacers, slingers, so on and so forth. The spindle chuck assembly. The outer part of the assembly is the spindle. This is where the impeller and bearings are pressed onto. The inner portion is considered the chuck. So what you guys were actuating with the tool or with the button, that's the chuck, the inner portion with the teeth. The outer part is just the spindle. There's two types of spindles. Most spindles are the same diameter throughout the spindle. With this type of spindle, you can push the bearings and the impeller from the same side. You can push them on in any direction. It basically looks, with nothing on it, it looks like this. There's your burr, there's your button. It's just smooth throughout the whole way. We had to take art class to teach. Okay. The second type, which is you'll find on a lot of European, Cavo W&H, and we just stumbled across the new, from Handpiece headquarters, the Midwest Stylists, have what's called a step spindle, where they have a larger diameter in the center where the impeller is, and it looks something like this. So it's going to come down, it's going to have a section here. Oops. That's not right. So, wow, that's bad. There's your button, there's your burr. So it's going to have a larger section like this. Obviously that means you can't take your press and press everything off this way, because your bearing is going to stop here and then explode if you try to get past this giant ridge. We're going to learn how to take them apart when you have this style versus this style. But these are the two styles you're going to see. The issue in lies is when it's all assembled and it looks all pretty, you can't tell which one is which because it's all assembled. So as we go through this, we'll explain to you and show you which ones you should automatically just assume is done this way versus doing them this way. Just so that you don't have that problem with exploding a bearing or breaking your press. And again, like we talked about, nothing should be done with Hercules type strength. So if you're trying to disassemble a handpiece, with these presses, everything should kind of be taps, a little bit of pressure, nothing you should need to just slam that press down. If you're tapping that press and you're trying to work that press properly and it's hung up and you think something's just not right, it's just not moving, chances are you may have one of these step spindles, and that's why you're trying to push everything past here and it's just not going to go anywhere. At that point you stop and you go, all right, let's do it the other way, which I'll show you, and then you'll probably get it apart a lot easier. And that's down here. Pressing the bearing over this raised section of the spindle will compromise the integrity of the bearing, and the bearing will fail prematurely. That should actually read, the bearing will explode. The bearings I've seen them will just disintegrate into nothing. You guys will destroy bearings here, but that's fine, that's what you're here for. Destroy my handpieces, break the parts of them, that's fine. I'd rather you do it here than when you're in a doctor's office trying to fix his. So don't be afraid if you're doing something wrong to, if you break something. We have plenty of replacement parts for these handpieces. So that's what you're here for, break them, damage them, and then eventually, by the time you leave here, you should be going, all right, I got this. So
make your mistakes here.
Yep. First handpiece you repair will probably take you an hour. I promise, once you launch it, will not take you an hour. I say it, and again, it's not to brag or anything, but I can repair these handpieces in literally about a minute or two. So once you get the hang of it, that's how quick it is and that's how simple it is. They're not rocket science. They look that way in the beginning, but I promise you they're not. The last week you're here, I actually put you on a timer to repair handpieces, to repair, invoice, the whole 9 yards. Try to give you a little bit of stress like you're in the field. It ends up working out pretty good because then when you get in the field, you're kind of prepared to go a little bit faster. We touched on these briefly before. The three types of chucks you'll see in the high-speed handpieces are the auto chuck is probably the most common. That's going to be your push button. And if you're working on a Midwest, your lever. The manual chuck, which is the keys. And then your friction grip, which I don't think you're going to see too many of those out in the field anymore. When we get into testing the handpiece, is the auto chuck is the only handpiece you should be doing a pull test with. We'll get into a pull test, but basically what that does is you insert a special tool into the burr of the handpiece. Got pull testers out here somewhere. Here's one as an example. So this is the size of a burr. You would insert this burr into the handpiece, and then you go ahead and you pull. It's spring loaded in here. Okay, that failed. So that if this was in the field and the doctor gave you this just failed a pull test, which means you need to replace everything. If you put this in here and you pulled out, there's a little score mark on here. Okay, you can see the score mark right there. If it reaches that score mark, it passes a pull test. That means you don't need to replace the chuck. Okay, we'll get into replacement parts in a little bit, but this is going to be, you're going to have a different variation of this on your truck, but this is going to be what you're going to do as one of your first tests when you get a handpiece from a doctor. You're going to do a pull test on it and see if the chuck is good or bad. He may tell you, hey listen, I was running this handpiece on a patient before and the burr just fell out. Key sign right there that the chuck is bad on it, the burr's falling out. Or he'll tell you it's starting to walk on him a little bit. As he's drilling, it's slowly starting to walk out. Again, a sign that the chuck has gone bad or is going bad. And that's what these pull tests help you identify in the field, to just confirm that, yeah, you know what, I go to pull this out just like on this one, it doesn't stay. So that's confirmation that the chuck is bad. Manual chucks with the key, again, because it's got that key, kind of like a drill press where you can just crank that key down around the bit, there's no point in pulling it, because unless the chuck is really gone, which I don't think I've seen before, you could just crank that key down and get it to pass a pull test. So you'll never pull test a manual chuck or a friction grip handpiece. The only handpieces you'll test is if you get one on your truck with a button or a lever. When we get into bearings, there's 3 different styles of bearings that you're going to see. You got a smooth bearing, a stepped bearing, and a flanged bearing. Your smooth bearing is pretty simple. Your smooth bearing looks like this. It's just smooth all the way around. That's it. Your stepped bearing kind of looks like this. Has a little step on the bearing. Okay? With these two, the key thing to remember is the O-ring will always go inside the handpiece or inside the back cap. Okay? Anytime you have a smooth bearing or a step bearing, the O-ring goes inside the handpiece or inside the back cap. The last one you have is a flanged bearing. The flanged bearing looks like this and has a much larger flange at the rear of the bearing. With a bearing like this, your O-ring is actually going to be seated on the bearing. So your O-ring will actually be seated right here. Because of that flange, it's going to hold the O-ring in place. Smooth stepped, the O-ring is in the head or in the back cap. Flanged, the O-ring is around the bearing. You'll see on some Cavos, they use a smooth in the front and a stepped in the back. Sometimes they use 2 steps. Also with Midwest, you're going to see a smooth in the front and a flanged in the back. So in that case, your front O-ring would go in the head, your rear O-ring would go on the flange. So you just got to pay attention to when you're taking these handpieces apart and you separate the head and you actually see the components, just pay attention to which bearings you're working with. And it'll help you identify where your O-rings are and how you need to apply them when you're putting the handpiece back together. The internal components of a bearing. The cage material in the bearing is what keeps everything together, keeps the balls nice and spaced. Everybody's familiar with a ball bearing. You've got little balls inside of a cage material, and that's what it rides on. The cage material is what keeps that properly spaced. If the cage material breaks or starts to fall apart, the balls can shift and the bearing won't run smoothly. You'll notice a little bit of wobble. The doctor will tell you there's just no torque. Chances are the cage material's probably broke and the balls have all shifted and they're just not where they should be. The cage material is usually what breaks down first. That's usually what falls apart and starts to disintegrate first. Cage material in most of your handpieces and most of your bearings is made out of plastic. Everything else is metal, so naturally that's what's going to fail first. Reason for the cage material to usually break down is they're not lubricating it properly, which means the handpiece is getting hot. Obviously heat, plastic, everybody knows what happens with that. It's going to start to fall apart, warp, disintegrate. Dirt particles, if they're not cleaning, that lubricant that they're using is also a cleaner. Helps clean any gook and grime out of the inside of the handpiece. Too much air pressure. Most of your handpiece manufacturers recommend anywhere from 35 to at most 40 psi. Should never exceed 40 psi. Okay? Some handpiece manufacturers even recommend down to like 33, 35 pounds of pressure. You'll get doctors out there who like to tittle with everything, and they'll go inside their delivery unit and they'll crank up their air pressure to 60. It allows the handpiece to run faster, right? It's kind of like more horsepower in your car. It allows it to go faster. But the problem with that is it wears everything a lot quicker. If you notice a doctor is doing that, you need to tell him, hey, listen, recommended pressure is 40. If you want to crank it up to 60 when I leave here, that's fine. I'm not going to tell you how to do your job, but you're not getting a warranty on your handpieces. Plain and simple. I've declined plenty of warranties, and I know guys in the field have declined plenty of warranties because the doctor likes to crank up his air pressure. It allows him to get the burr spin faster. He feels he can cut faster, which means he can work faster. That's fine, dude. I'm not going to tell a doctor how to do his job. It's not what I'm there for. But I am going to educate him. I'm going to say, listen, recommended air pressure is 35 to 40 psi, proper lubrication, proper cleaning. What you choose to do when I leave here, that's your own business. I'm going to educate him. I'm going to make sure he knows what he should be doing, and then you let them take it from there. And that's where you have to do inspections on handpiece warranties. If a doctor gives you a handpiece back, hey, you fixed this a month ago, it's not working again. Why is it not working again? Was it just the parts failed prematurely, or were they mishandling the handpiece? Were they not lubricating it properly? Was the doctor cranking up his air pressure? So you guys have to do a little bit of investigative work before you say, okay, I'll take care of that for you. Find out what he's doing or what he's not doing, and then take it from there. Types of ball bearings, there's stainless steel and there's ceramic. Ceramic obviously is a better material than the stainless steel. It runs cooler. The issue with the ceramic bearings is it still uses everything else is the same, it's just different ball bearing types. A lot of your high-end manufacturers only use ceramic bearings. The cage material that's inside of the bearings, the most common you'll see is a polymer cage material, which has a very high resistance to the autoclave, but it's got a lower wear and tear resistance. Autoclaves, when working properly, reach temperatures of about 273 degrees. So obviously anything in the dental field that's getting sterilized needs to be able to handle that type of heat and 30 pounds of pressure. Phenolic is the other cage material, which is a low resistance to the autoclave but a high resistance to wear. I don't believe you're going to see too much of the phenolic cages out there. Mostly everything you're going to see is the polymer cages. Just because these handpieces, when they're being taken care of properly, should be in the autoclave after every single use. As soon as the doctor's done with his procedure, the assistant should get that handpiece, wipe it down, make sure there's no blood, debris on the handpiece, lubricate it, and then sterilize it. Should be done after every single patient. So that's why most of the cage materials you'll see is polymer, because it has a high resistance to the autoclave, and they should be seeing the autoclave a lot. There's two types of bearings in the dental field. You're going to see a radial bearing and an angular bearing. The radial bearing is going to be your most common, inexpensive bearing out there. It's smooth through and through. On the inside, we're talking about the inside part now. So forget the outside when we talked about smooth stepped flanged. We're talking about the inside part of the bearing at this point. Radial bearings are easier to work with and they're less expensive. They have full shoulders on the inner and outer ring. Okay, so inside of where this ball is sitting, there's a little groove, which obviously gives you a shoulder on both sides. Okay, it's a lot smoother. It gives you a little bit more leverage, or not leverage, a little bit more ease of mind when you're working on them. If you accidentally put a bearing on backwards, because there is a front and a back to a bearing, it will allow you to press it off and flip it and put it back on the right direction, because it does have the shoulders on both sides. Okay, it's a little bit more inexpensive bearing, kind of like the workhorse of the bearing. Next you have is angular. If you notice the difference with angular, there's only a shoulder on the bottom here. Okay, this is kind of a little ridge here that comes off and goes flat. The thing with angular bearings is if you press them on backwards, they will fall apart. A brand new bearing, you're going to look at it and you're going to go, oh, it's a brand new bearing, I just put it on. Why is it in 5 different pieces? Well, because you got an angular bearing and you put it on backwards. Okay, these will run a lot better. They're a lot better of a bearing to operate, but they're a lot more temperamental when you're putting them back together. So as we go through the training, and we're going to go on Handpiece headquarters website, that's where you're going to get a lot of your diagrams from, that's where you're going to get your parts breakdowns from. They will tell you, like as an example, I'll pass this around, and if I can find angular. Okay, well, this one's open, so just be careful. If you look at these two, angular contact, radial. Okay, so a lot of the bags will be labeled angular or radial. So you have to just pay attention to what you're working on. Again, the radial will give you, be a little bit more forgiving if you do something wrong. The angular, if you do something wrong, you probably just compromise the entire bearing and you just wasted a bearing. You visually aren't really going to be able to see this. Unless you plan on inspecting every bearing under a microscope, you're not going to be able to see this with the naked eye. Okay? You just have to pay attention to what's written on the packet or what's written on Handpiece headquarters website. Okay? This is important to pay attention to. Installation of the bearings. There are 2 sides to a bearing. The side that goes against the impeller and the side that goes away from the impeller. In most instances, the side that goes towards the impeller shows the black caged material. The side that goes away from the impeller shows either the shielding of the bearing or the actual ball bearings themselves. We like to tell you keep your balls away from the impeller. Okay? If you put a bearing on backwards, especially an angular bearing, it will fall apart. If we're talking about these bearings over here, this one is obviously a little bit more tricky to tell the front and the back. It's smooth all the way around. So how you tell is you have to inspect the bearing and find either the black cage material or you have to find the shielding. Okay? Remember, if it's got shielding or the ball's showing, it goes away from the impeller. On these are a lot easier because this section here, this here, and this here goes against the impeller. So basically they're going to sandwich the impeller in the middle. So these are much easier to identify how to put them on properly. You don't have to worry about balls out, cage material, shielding when you're dealing with a stepped bearing or a flanged bearing. The step and the flange always sandwich the impeller. Okay? So they're going to basically look like one's backwards and one's forwards, because that's how they're going to sandwich. This, the smooth bearing, is where you have to pay attention to cage material, balls out, shielding. when we get into invoicing, serial numbers must be recorded on all your invoices. Must, must, must. There is a section on invoicing when we get into it that is specifically designed for your handpiece information. Make, model, serial number, and the warranty period that you're giving. Okay? Each handpiece has a serial number on it. If you happen to get a handpiece that does not have a serial number, chances are you're working with a off-brand, knockoff, third world country handpiece. Okay? The serial number on your invoice obviously helps you track your warranty purposes. So if a doctor gives you a handpiece and he's going to go, oh, I think you might have repaired this recently, you can type in the serial number into our software and it'll populate every invoice that's related to that serial number, and you can tell the doctor, hey, listen, I didn't repair this thing for over a year. You don't have a warranty on it. Or, hey doc, yeah I did, I repaired this about 2 months ago. Excuse me, let me do a little bit of investigation, see what's going on with it, and we'll talk about warranty, you know, after I do my little investigative work. In order to get a warranty from Dentalfix or your suppliers, you need to have that invoice. So if you have an invoice dated today, and 2 months from now the doctor calls you and you do your inspection, his air pressure's at 40, he's lubricating properly, he's taking care of his handpiece properly, and the chuck failed, the burr pulls right out. That could be a legitimate warranty claim. But the manufacturer you're getting the warranty through, whether it be Handpiece headquarters or one of our other vendors, they're going to want that original invoice to show the date that you did that repair, that it is within the proper warranty period. And it has to show the invoice with the date and serial number and the make and model of the handpiece before they will say, okay, we approve your warranty. So make sure you're recording all your information down. Handpiece headquarter does not put serial numbers on the internal components, so you don't have to worry about that. HPP, Handpiece Parts and Products, we don't do too much with them anymore, but they actually put a serial number on the impeller. You need a magnifying glass or really good eyes to see it. It is very small, not easy to find. Here's one with it. Obviously having the lights off doesn't help, but I'll pass this around, and you see that little white writing right there on that blade?
Barely.
Try to make it out. Yeah, barely, exactly. Unless you've got a magnifying glass, they're very hard to identify. But if you do get something from HPP and you're using it, keep track of those serial numbers also. Microtech puts a serial number on the back of the end spindle where the actuator is located. Microtech, really the only thing we buy mostly from Microtech are NSK canisters, which are also serial numbered on the back around where the button is. So again, if you're using parts that are serial numberized, record those numbers with the number, with the serial number of the handpiece. The more information you can keep track of serial number wise, the easier it is for everybody to deal with warranty claims and things like that. Done.